The other type of inequality is a greater than inequality, and that instead of an and will be an or, so we call it a greater than inequality. So in a greater than inequality, again, if we sort of go through some of the solutions that would work, if I plugged in negative 5, the absolute value is positive 5, and 5 is greater than 4, so that value would work. Positive 5 would also work by the same token, so the absolute value of 5 is 5, which is greater than 4. None of these values in the middle would work because when I take their absolute value, they are simply less than 4, which we learned in our previous video. The negative 4 and the positive 4 would not work, but all of the numbers very close to that would. So we would look at something like this, where any number that is less than negative 4 would work, because negative 10 or negative 20, when you take the absolute value, turns into a positive 10 or a positive 20, which is greater than 4. Same thing on the positive side. Anything greater than 4 would, of course, be greater than 4. So this is what my graph would look like. And if I were to generalize my results, I would say negative infinity up to negative 4. And on this side, it would be from 4 on to infinity. And you might see this written with an or in between. Probably you'll see it written with the union of sets in between. So all of the values would be from here and then from here. 4 to infinity, negative 4 to negative infinity. Those would be our values. So let's take a look algebraically what we would do here instead. So here, the first time I would write it as x is greater than 4. And then I would write or, the actual word or, x, and then I'm going to flip it and change the sign. So here are my two values. So basically we're saying it could be this, greater than 4, or it could be a value that's less than negative 4. If I were to graph that, again, an open parenthesis on the 4, shaded all the values that are greater than that. On this one, a negative 4 would have an open bracket and shade all of the values less than that. Let's see how we would solve this greater than inequality. So again, my original sign is a greater than. The first time I would write it as w plus 4 is greater than or equal to 7. And then I would write the word or, because it's a greater than, w plus 4 is less than or equal to negative 7. I would solve each just like I would if it were an equation, which gives me w is greater than or equal to 3, or w is less than or equal to negative 11. Both of those would work. And this one they want me to graph. So on my graph at negative 11, I would have a closed bracket, and I would shade all of the values less than negative 11, closed bracket because it was or equal to. On the other side, I would have a closed bracket on positive 3 and shade all of the values greater than that. On this example, I can't write my equation twice until I get the absolute value by itself. So I'm going to divide by 5 to get the absolute value of 2w plus 1 is greater than or equal to 3. Then I'm going to drop the absolute value sign and say 2w plus 1 is greater than or equal to 3, or 2w plus 1 is less than or equal to negative 3. Again, I'm going to solve using inverse operations on each example. My first solution gives me w is greater than or equal to 1. My second solution gives me w is less than or equal to negative 2, and again I would have that or in between. To graph the solution, at negative 2 I'm looking for values that are less than or equal to that, so that or equal to makes a closed bracket shaded to the left. W is greater than or equal to 1 gives me a closed bracket on 1 shaded to the right. For this example, I'm going to write it twice immediately because I don't have to isolate the absolute value because it's already isolated. The first time it's greater than or equal to 17. The second time less than or equal to negative 17. I will solve using inverse operations. For my first inequality, I get W is greater than or equal to 19/5. It's okay to leave that as a fraction, even as an improper fraction. For my second example, or my second inequality, I get W is less than or equal to -3. Again, I write the word or in between. To graph that solution, at -3, I would have a closed bracket shaded to the left because those are the values that are less than or equal to -3. At 19/5, I would have a closed bracket and shaded to the right. Try this example on your own, then press play to see how you did. For this example, I would start by isolating the absolute value by adding 12 to each side. That gives me the absolute value of x plus 9 is greater than or equal to 26. This is an or problem because it's greater than. So I will write x plus 9 is greater than or equal to 26, or x plus 9 is less than or equal to -26. I solve each inequality using inverse operations, and that gives me my two answers of x is greater than or equal to 17, or x is less than or equal to -35. To graph, I will put -35 to the left and 17 to the right. Less than or equal to -35 would be a closed bracket and then shaded left. Greater than or equal to 17 would be a closed bracket and shaded to the right.